pub owner claims that customers consume an average of 32 ounces of beer per visit. A random sample of 35 customers is selected. These customers consumed an average volume of beer of 33.1 ounces. The sample standard deviation was 4.2 ounces. Use the provided data to calculate a p-value in order to test the owner's claim. All right, so they want us to test a hypothesis, and they want us to use the p-value to do it. So let's start with the initial step, which is the claim. It says that the owner claims that the mean amount of beer consumed is 32 ounces. That would make the null hypothesis also that the mean is 32 ounces because it has an equal sign there. The alternative hypothesis then would be that the mean is not equal to 32 ounces. Now, the data for this problem will be essentially that the sample size is 35, right? They looked at 35 customers. Sample mean in the problem was 33.1 ounces, so that was the average volume for the sample. Standard deviation for the sample was 4.2 ounces. And then they tell us that they want us to use the p-value, but they do not give us a significance level, so we're going to use a default value of 0.05 as our significance level. So whenever they don't give it to you, you can assume 5%. All right, let's take the test stat then. The test stat here would be a z-test stat because of the large sample size. And the sample mean would be 33.1 minus the mean from the null hypothesis, which is 32. Then we're going to put the standard deviation of 4.2, and underneath that, the square root of the sample size, which is 35. Okay, let's work that out in our calculator. So open parentheses, 33.1 minus 32, close the parentheses, divide by 4.2. So open up a new parentheses, then put 4.2, divide by the square root of 35. Okay, and when we're done with that, we get 1.55 rounded to 2 decimal places. And it's important you round it to 2 decimal places because when calculating the p-value, you have to look it up on a z-chart, and that chart typically only has 2 decimal places. So we're going to say approximately 1.55. All right, so that's your test stat. Now we're going to take that test stat and we're going to place it on a bell curve in order to calculate the p-value, right? So here's how we do this. We basically draw a blank bell curve. We label 0 in the center as our reference point. That's our mean for the standard normal curve. We put 1.55 on the drawing. And here, because it's a two-tailed test, the rule is that we're going to shade the tail area beyond the test stat, and then we'll double that area to calculate the p-value. Again, I know it's a two-tailed test because my alternative hypothesis uses a not equal to sign. Let's go look up 1.55 on our z-chart. So it looks like 1.5 is here, and 1.55 is right here. So we have the answer 0.4394. So this is the area 0.4394, right? That's not the area we're actually looking for. So to get the area we want, we're just going to do 0.5 minus that area of 0.4394. And then we're going to multiply by 2 at the end. So times 2, and we should get 0.1212. And there it is. We have the answer then. So our p-value is equal to 0.1212. Now, once we have the p-value, we just have to compare it to our significance level. The rule is if the p-value is less than the significance level, you reject the null hypothesis. But here, the p-value is larger than alpha, right? So since the p-value is greater than alpha, we do not reject the null hypothesis. So do not reject HO. Do not reject HO. And that means that you do not support HA. You do not support HA, or the alternative. Now, which one of these statements should we say in our final wording? Well, since the original claim in this particular problem is the same as the null hypothesis, I think we should say we do not reject the claim. So we'll say here simply, do not reject the owner's claim. You can fill in the details after that if you want, but we're just saying, hey, this pub owner said that the customers consume on average 32 ounces. The sample mean was 33.1. It's very close to 32 ounces, so we're going to go ahead and say that the data does not allow us to reject that owner's claim, so we'll continue to believe the owner is correct about the average customer's consumption of beer.